Welcome to day 5, the most important day of the week and not by a small margin. This week you have learned to think about systems, to name building blocks, to design for quality, to produce a complete design pack. All of that has been preparation for today. Today you learn to write a feature spec. A feature spec sharp enough that an AI coding agent, Claude Code, or GitHub Copilot Workspace can take it and build the feature. Without 10 rounds of iteration, without inventing fields, without shipping the wrong thing. This is the skill that separates BISTEC interns from interns at other companies. Take it seriously. Today is the bridge into your career. Look how far you have come in 4 days. Day 1, you learned systems thinking, context, requirements, invest stories. Day 2, you learned building blocks. A P is databases, caches, queues. Day 3, you learned quality, scale, reliability, security, observability with measurable targets. Day 4, you learned end-to-end design, diagrams, a DRS, trade-offs, design review. Today, day 5, all of it pays off. You learn to write a feature spec sharp enough that a Claude or Copilot agent builds it right first try. 5 concrete skills. 1. Explain why specs matter even more in an AI-augmented workflow. 2. Write a 7-section feature spec, why, scope, contract, acceptance, examples out of scope, open questions. 3. Author given / when / then acceptance criteria that an AI agent can drive an implementation against. 4. Spot 3 classes of spec: smell, vagueness, hidden assumption, embedded solution, and rewrite each. 5. Run a structured spec review. Give and receive feedback using a rubric. Before AI, the bottleneck in software was typing speed. Engineers were valuable because they could type fast and write working loops. Now the bottleneck is thinking. The AI types in seconds. What it cannot do is read your mind. Before AI, rough spec, lots of code, iterate over weeks. Cost of a vague requirement, weeks of rework. Engineers value typing speed with AI tight spec. The AI writes code in seconds. Ship. Cost of a vague requirement, seconds, but multiplied across many wrong attempts. Engineers value thinking precision. The shift means the spec, the artifact you write to capture intent, has become the most valuable document in the workflow. Get it right, the AI delivers. Get it wrong, the AI fails fast in many directions at once. Knowing this is the foundation of using AI productively. What AI agents do well, translates clear intent into code fast, handles boilerplate, scaffolding, plumbing, refactors with full file context, generates tests from specifications, explains code it has just read. What AI agents do badly, inventing what you wanted but didn't say, knowing your team conventions without being told, pushing back on bad requirements, long-running multi-step tasks without checkpoints, realizing that it doesn't know something, it tends to confidently make things up. Your job, as the engineer driving the agent, is to remove the things it does badly. Write a spec so tight that it has nothing to invent. Tell it your team conventions. Push back on bad requirements before you prompt. Break long tasks into checkpointed steps. The biggest mental model shift this week. The spec is now the artifact people review. The code is what the AI produces from it. Reviewers and AI agents both work from the same document. Old workflow, open a ticket, write code, open a PR. The reviewer looks at the code, iterate. New workflow, open a ticket, write a spec. Spec review by your peers and senior. The AI generates code from the spec. Quick code check, ship. The implication. Your spec quality determines your team's velocity. A great spec ships in hours. A vague spec wastes a day, possibly more. This is why we spend a whole day on spec writing. It is the new core skill. Each silent assumption in your spec creates a fork in what the AI implements. 3 ambiguities can produce 8 different implementations, most of them wrong. Without a tight spec, you give the AI a vague brief. It guesses 3 things. They are all reasonable, but only one matches what you wanted. 2/3 of the code is wrong. You iterate, you explain, you reprompt. Each round adds time. With a tight spec, you wrote down the 3 things up front. The AI has nothing to guess. It implements the spec. You are done in one pass. Code review is short. You ship. This is the math of spec quality. A spec with 1 silent assumption costs roughly twice as much. 2 silent assumptions 4 times. Eliminate them up front. Given slash when slash then is no longer just for the QA team. It is the contract the AI implements against. The flow, step 1. You write given slash when slash then in the spec. Given a rider has confirmed a booking 90 seconds ago, when they tap cancel, then the booking is canceled with no fee. Step 2. You paste the spec into Claude or Copilot. You add a single instruction implement so that all the given slash when slash then below pass. Step 3. The AI generates code and tests. Both come from the same source. The tests check the code. Step 4. You review the tests first, the code second. If the tests pass and they match the spec, the code is correct. This is incredibly powerful. The same artifact drives implementation, drives tests, and drives review. One spec, one source of truth. Here is the structure. 7 sections. If your spec is missing anyone, the AI will guess. Don't let it. Why? The user or business outcome we are solving. If missing, the spec becomes a solution looking for a problem. Scope, the boundary of this change. If missing, scope creep mid-implementation. Contract, inputs, outputs, errors, side effects. If missing, the AI invents the contract. Acceptance, given slash when slash then tests that must pass. If missing, done cannot be defined. Examples, concrete and out pairs. If missing, edge cases drift out of scope. What we are explicitly not doing. If missing, the reviewer will ask, why didn't you also? Open questions, what we don't yet know. If missing, decisions made silently in code. Memorize these 7. Use them as a checklist on every spec. Section 1. Why? The purpose. The user or business outcome we are solving. The metric this feature is expected to move. An example, why we are building this. Claimants currently spend 4 minutes per claim. Most of that time is choosing the right expense category from a long list. We want to reduce time per claim to under 2 minutes by suggesting a category from the receipt photo. Notice, the why has a measurable target under 2 minutes. Not make it easier, not improve user experience, but a concrete number you can measure before and after. That is what makes a why useful. Section 2. Scope, the purpose, the boundary of this change, which containers and components are affected, which are not. An example, in scope, adding 1 new endpoint to the claims, a PI. Adding a categorizer component inside the claims, a PI service. Affects the claims, a PI container, the mobile app's claim submission screen. Not affected, the database schema, the audit log, the payment service. Notice, scope is a yes or no for every container. The AI knows exactly which files to touch and which to leave alone. No accidental changes to neighboring services. Section 3. Contract, the purpose. Inputs, outputs, errors, side effects, the shape of the change. The contract has 4 parts. Inputs, POST to slash claims with a body containing the receipt image, JPEG or PNG up to 10 megabytes. Outputs, 200 OK with a JSON body containing category, confidence, and source. Errors, 400 for bad input. 413 for too large, 502 for upstream unavailable. Side effects. An application insights custom event named Categoriser.suggested is emitted on every call. The 4 parts. Be complete. The AI is excellent at building contracts, but only if you told it the shape. Section 4. Acceptance criteria. The purpose. Given slash when slash then tests that must pass. These are also what the AI implements against. An example. Acceptance criterion 01. Happy path. Given a receipt image of a restaurant bill totaling 2,400 Sri Lankan rupees. When the claimant uploads it via POST to /claims/brace ID/receipt/categorize, then the response is 200 OK with category equals meals and confidence greater than or equal to 0.7. And source is LLM. And a custom event Categoriser.suggested is emitted within 5 seconds. That is one criterion. Most features need 6 to 10 such criteria, covering happy path, ambiguous case, fallback, error path, and privacy concerns. We will see more in the challenge. Section 5. Examples, the purpose, concrete and out pairs. Anchor the AI's understanding with real data. Example 1, the happy case. Input, a restaurant bill image, total 2,400. Output, a JSON response with category meals, confidence 0.84, source LLM. Example 2, the ambiguous case. Input, a mixed receipt with food and stationery. Output, category other, confidence 0.45, source LLM. Below 0.6 shows as needs review. Example 3, the error case. Input, a 15 megabyte image over the limit. Output, 413 payload too large. 3 examples. Happy, ambiguous, error. The minimum viable set. Section 6. Out of scope, the purpose. What we are explicitly not doing stops the AI and the reviewer from asking why didn't you also? An example, out of scope for version 1. Multi-receipt batch upload, only 1 receipt at a time. Auto-submission without claimant confirmation, always show the suggestion and let the user accept or override. Learning from overrides through active learning, logged for future training but not used live yet. Receipts in languages other than English, Sinhala and Tamil, OCR comes in version 2. The discipline of writing what is not in scope is harder than writing what is. It forces you to be honest about boundaries. Section 7. Open questions, the purpose. Things you don't know yet. Surfacing them stops you from making decisions silently in code. An example, open questions to resolve before merge. Question 1. What confidence threshold should trigger needs review? Currently guessed at 0.6. Need finance to confirm. Question 2. Who pays the LLM a PI cost, central engineering budget, or per business unit? Affects whether we need a per claim cost tag. Question 3. If the LLM is unavailable, should we charge nothing or show a fallback rule-based suggestion? Current spec says fallback. Needs product sign-off. Open questions are not weakness. They are honesty. Senior engineers welcome a spec that names what it does not know. Junior engineers hide unknowns and create surprises later. Now 3 smells. The most common one is vagueness. Adjectives without numbers. Words like fast, secure, user-friendly, scalable, they feel meaningful. They are not. The smell. The system should be fast and handle many users. The rewrite. Suggestion endpoint returns within 4 seconds at the 95th percentile at 50 concurrent claimants per the load test in test/load/categoriser.k6.js. Notice the difference. The rewrite has numbers, a method, and a verifiable test file. The original has wishes. The rule. If you cannot put a number on it, do not put it in the spec. Adjectives are wishes. Numbers are commitments. The second smell is hidden assumption. Obviously, something is true, but it is not said. The AI guesses. Sometimes wrong, the smell. Show the price to the rider. The hidden questions: in what currency, before or after discount, including tax, rounded to what, the rewrite. Show the final fare in Sri Lankan rupees, rounded to 2 decimal places, including all taxes and any active promo discount applied. The test: if you wrote a sentence and a non-technical reader could ask, but what about X? X is hidden. Surface it before you ship. The third smell is embedded solution. Design dressed up as a need. The spec says how when it should only say what. The smell: use readies to cache the search results. This is a solution, not a need. The actual need is hidden behind it, the rewrite. Repeat searches within 30 seconds should not hit the database again. Then move the choice of caching technology to open questions or to a separate DR. The discipline: specs say what, design says how. If a sentence in your spec mentions a specific technology choice, demote it to open question or move it to a design decision document. This is the hardest smell to spot in your own spec because the technology feels obvious to you. Train your reviewer to call it out. When the spec drives the AI, your prompts should be short and structured. 5 rules. 1. Lead with the spec, not the question. Paste the entire spec before any instructions. 2. Anchor on acceptance criteria. Implement so that all the given slash when slash then below pass. 3. Constrain the toolbox. Name the languages, frameworks, and file paths the agent should touch. Tell it what not to add. 4. Ask for the gaps it sees. Before you code, list any spec ambiguities you would want resolved. 5. Iterate on diff, not on chat. Keep the spec as the source of truth. Let the agent reread it on every iteration. Here is the prompt template. Use it as a starting point. You are implementing a feature in TypeScript. Below is the complete spec and acceptance criteria. Implement the feature so that all acceptance criteria can be made to pass with a small test runner. Constraints: touch only files under src/categorizer/ and test/. Use the existing logger. Do not add new dependencies. Do not invent fields, endpoints, or behavior not in the spec. Before writing code, list any ambiguities in the spec you would want clarified. Then paste the spec .markdown. Then paste the acceptance .markdown. Notice, the instructions are short. The spec does the heavy lifting. The constraints prevent the AI from inventing things. Tell the AI exactly what test runner to satisfy. The acceptance criteria become executable. Look at the example. The test imports the categorize function from your source. Test 1. Acceptance criterion 01, the happy path with a clear meal receipt. Call categorize with a meal receipt fixture. Expect the category to be meals. Expect confidence to be greater than or equal to 0.7. Expect source to be LLM. Test 2. Acceptance criterion 03, the LLM is unavailable. The categorizer falls back to rule-based. With a fake LLM returning 503, call categorize. Expect source to be rule-based. 2 tests, 12 lines of code. The AI generates them, runs them, makes them pass. You review the diff. Without constraints, the AI invents new dependencies, new file structures, new patterns. Tell it what you have and what you do not want, what to constrain. Language and version: TypeScript 5, Node 20. Frameworks: Express, Vitest. Do not add new web frameworks. File paths: touch only src/categorizer/ and test/. Style: match existing code style. Do not add prettier or ESLint changes. What to forbid: inventing fields not in the spec, adding new NPM dependencies, editing other modules, hiding work in commit messages. Refactor should mean refactor, not secretly added a feature. The senior engineer's habit. Write your constraints once, save them as a snippet, and paste them into every AI prompt you make. Consistency in constraints buys consistency in output. Now the challenge. Receipt Categoriser, the brief. Add a feature to GreenChit. Given an uploaded receipt image, suggest one of 5 expense categories with a confidence score. Below 0.6 is shown as needs review. The claimant can accept or override before submitting. Falls back to rule-based if the LLM is unavailable. Your job. Write the spec sharp enough that an AI agent, Claude, or Copilot Workspace builds it correctly the first time. Then drive the AI. Paste your spec, drive the agent, capture each prompt and response, document where it deviated. Then peer review. Swap specs with another pair. Run the spec review rubric. This is your week's capstone. Take it seriously. Same shape. 100 points total. Pass mark 75. Deliverable 1. The feature spec. All 7 sections. Why scope, contract, acceptance, examples out of scope, open questions. Deliverable 2. Acceptance criteria. At least 6 given / when / then including a happy path, an ambiguous case, a fallback, an error path, and a privacy check. Deliverable 3. The AI implementation report. Prompts and responses captured verbatim. Where the AI deviated from the spec. Tests passing. Code structure clean. Deliverable 4. The spec review. Feedback given to and received from another pair. At least 5 smells identified across both. A reflection on what surprised you. When you review a spec, yours or someone else's, run through these 6 checks. 1. Is the user benefit clear? Why are we building this? What metric moves? 2. Is the contract complete? Inputs, outputs, errors, side effects, all present. 3. Are acceptance criteria observable? Could a tester verify them without asking the author? 4. Are out-of-scope items explicit? At least 3 things named that could be in scope but aren't. 5. Are there at least 3 examples, including 1 negative? Edge cases anchored. 6. Are open questions actually open, or did the spec choose silently? Print this rubric, pin it. Use it on every spec review you join, including your own. Pause and feel this. 5 days ago, many of you had not seen a context diagram. None of you had run a design review. None of you had written a spec for an AI agent. Today, you can do all of these. Day 1, you can capture requirements, draw a context diagram, hunt ambiguity in a brief. Day 2, you can choose the right building blocks, design a REST API, draw a container diagram. Day 3, you can apply scaling, reliability, security, and observability with measurable targets. Day 4, you can produce a complete design pack with diagrams, a DRS, and a defended trade-off. Day 5, you can write a spec sharp enough to drive an AI agent and review another's spec. That is a senior intern's worth of skill, compressed into 1 week. Be proud. This week was the bridge. Now you join your team and ship real work. Week 2 onwards, you join the engineer track or the role you were hired for. Monthly 4-hour sessions. Layer in AI adoption track modules once you are comfortable with spec-driven development. Habits to keep. Always start with a spec, even for small changes. Write a DRS as you decide, not after. Maintain a learning log.md weekly for the first 8 weeks. Where to ask for help. The cohort teams channel. Your assigned buddy. Senior on call, that is the Friday office hours. The skills you learned this week are now the BISTEC standard. Use them. Refine them. Teach them to next year's intern cohort. A small habit that pays dividends every time you change role or apply for promotion. 1. Pair with a senior on one real ticket. Turn it into a spec before any code. 2. Maintain a learning log.md weekly entry for your first 8 weeks. What you learned, what tripped you up, what worked. 3. Build a portfolio repo. 3 specs you wrote plus the AI sessions that delivered them. Public on your GitHub if appropriate. 4. Schedule a 30-minute check-in with your buddy at week 4. Review your spec quality. Adjust. 5. Read 1 chapter of The Pragmatic Programmer each week of your first quarter. Discuss in the cohort channel. Your career compounds. The habits you start now matter more than the language you happen to be using today. That is the week. Take a moment to feel it. 5 days ago, you were 10 strangers from 10 different schools. Today, you are 10 colleagues with a shared vocabulary and a shared toolbox. Your team is waiting. Go build something. Welcome to BISTEC.